Hello, Year 8. I hope you're all doing well, staying safe, and making the most of your time at home. This is Miss Yang speaking, and I'm going to be guiding you through this PowerPoint. Today's lesson is on the topic Area of 2D Shapes. I will be using the normal I-We-Use structure for this lesson. I would suggest you copy down the I do examples which you think are difficult, and make sure you do all the we do tasks in your books and mark your work in red pen. Okay, let's get started. These are the Heggerty Maths clips you did in your last lesson on Wednesday. If you didn't manage to finish, it might be a good idea to do those first before you come back to this lesson. You should now be confident with finding the area of simple 2D shapes like rectangles, triangles, and trapeziums, and some slightly trickier compound shapes as well. Here are some of the key area facts you need to know for this topic. Please pause the video and copy down these facts neatly into your books. You may also want to draw a box around them or highlight this part so that it stands out. Before we go to the next slide, I just want to quickly go over some common misconceptions. For example, for the area of a triangle, I know lots of people forget to divide the base multiplied by height by 2. Make sure you don't forget that, because without dividing by 2, you'll just be working out the area of a rectangle with those same dimensions. Wherever you see height, you must make sure that this is perpendicular to the base. What does perpendicular mean? It means it is at a 90-degree angle to the base. Examiners like to trick you and give you the length of the slanted side of shapes, but you must remember to always use the perpendicular height with the base. Here is your first example. We have a compound shape which consists of 2 rectangles joined together. The question has given us the perimeter of the shape, 36 centimeters, and has asked us to work out the area. The perimeter is the distance around the outside of the shape. Some of the lengths are missing from the diagram, which means we must work them out first before we can find the area. So we can see that all the horizontal lengths of the shape have been given to us. If I add these lengths together, it gives us the portion of the perimeter that accounts for just the horizontal sides of the shape. This would be 3 add 3 add 6, which is 12 centimeters. If I subtract that from the perimeter of the whole shape, this would give me the sum of the remaining sides, which are the vertical ones, and that is 24 centimeters. The next thing I'd do is recognize that side A is equal to the sum of sides B and 5. That means that essentially the perimeter of this shape is 12 centimeters. That's the sum of the horizontal sides, add 2 lots of A. So that means if I divide my remaining perimeter by 2, it gives me side length A, which is 12 centimeters. To work out side length B, I will use my knowledge that B add 5 gives us A, and subtract 5 from 12 to give us 7 centimeters. Now we have the lengths of all the sides. We can work out its area by dividing the compound shape into 2 rectangles. I have split it up along this dotted line. The area of the rectangle on the left would be length multiplied by width, or 12 multiplied by 3, which is 36. And the rectangle on the right would be 3 multiplied by 5, which is 15. Finally, I add the 2 areas together to give me the area of the whole shape, 51 centimeters squared. Now, pause this recording and have a go at the we do on the right. Make sure you write down your working in your book and move on to the next slide when you are finished. Check your answer using red pen and write in the correct solution if you didn't manage to get it right. Here is your second example. This question tells us that a square has an area of 25 centimeters squared. You must work out the perimeter. We know that a square is a four-sided shape with equal side lengths all around. This means the area of a square is length multiplied by length, or length squared. If the same number is multiplied by itself to give 25, we can work out what that number is by square rooting 25. Therefore, one side length is 5 centimeters. But we haven't finished yet. We need to work out the perimeter of the square, and that would be 4 lots of 5 centimeters, which is 20 centimeters. Notice how my units are given in centimeters, not centimeters squared, because we're working out a perimeter, not an area. Now have a go on the We Do question in your book. Pause the recording to give yourself enough time. Check your answer and mark your work with red pen, writing in the correct solution if you did not get the same answer. Example 3. The area of the triangle is 18.5 centimeters squared. Work out the missing length. We're given a couple of different lengths of this triangle, but we only really need two of them, the base and the perpendicular height. Looking at the diagram, it's pretty clear which ones they are. They must be the missing length and 3.7. I know that the area of a triangle is base multiplied by height, all divided by 2. So, to work out the missing length, I would have to work backwards from the area by multiplying this by 2, so 18.5 multiplied by 2, which gives me 37, and then dividing this answer by the height, which gives me 10 centimeters. In these reverse area questions, it's important you check your answer to make sure you haven't made any silly mistakes. So let's work out the area of the triangle given this new length that we've just worked out and see if it gives us the area of 18.5 centimeters squared. Okay, so base multiplied by perpendicular height would be 10 multiplied by 3.7, which is 37 centimeters squared. Then I would divide that by 2, and that gives me 18.5 centimeters squared. This is how I know that my answer is correct. Now have a go at the We Do in your books before you move on to the next slide. Don't forget to check your answer at the end. 10 centimeters was the correct answer. Well done. Next is a parallelogram question. Work out the area of the following parallelogram. All measurements are in centimeters. To work out the area of a parallelogram, you multiply the base by its perpendicular height. I can see that if the base is 3.5 centimeters, the height must be 4 centimeters, as side length 5 is not at a 90-degree angle to the base, since it's on a diagonal. Therefore, I would do 3.5 multiplied by 4, which is 14 centimeters squared. You can use your calculator for these, but really all of you should be able to do this using column method, or even better, in your head. Try the next one now in your books and be prepared to mark your work before you move on to the next slide. Example 5. This time we're given a trapezium. Work out the area of the following trapezium. All measurements are in centimeters. To work out the area of a trapezium, we have to add the two parallel sides. These are the ones that have the arrows on them. Parallel means that the sides or the lines will never meet. Divide your answer by 2 and then multiply this by the perpendicular height. Here are my two parallel sides, and here is my perpendicular height. So I would do 4 add 2, all divided by 2, and then multiply that by 3, That gives me an answer of 9 centimeters squared. Notice how I didn't use 3.6 for my calculation, as that information was not relevant for this question. Now pause the recording and have a go at the we do in your books. The correct answer was 13.5 centimeters squared. Well done if you got that right. If not, pause the video to write down the correct working and solution into your book. Example 6. Here we are given two shapes and asked if they have the same area. Again, the measurements are given in centimeters. To compare the two shapes, we must first work out the area of each of them. Let's start with the shape on the right. The little lines on the sides of this shape signal to me that they are all of equal length, making this shape a square. To work out the area of a square, I square one of the sides, which is 3 squared, to give me 9. The shape on the left is a four-sided shape with a pair of parallel lines. This is a trapezium. To work out its area, we would add the two parallel side lengths together, divide this by 2, then multiply the answer by the perpendicular height. That's 2 add 4, all divided by 2, multiplied by 3, which is 9 centimeters squared. Now we can see that the two shapes have the same area. Now try the we do, and be prepared to mark your work before you move on to the next slide. Excellent work, Year 8. Now it's time for you to practice what we've learnt. Here is your you do task. Put 10 minutes on the timer and have a go at the following questions. Use your notes to help you, and if you're stuck, you can go back to previous slides to remind yourself of how I answered a similar example. Once that timer goes off, check your answers on the next slide and mark your work in red pen. Don't forget to write in full solutions for the questions that you didn't quite get. You're so close to the end now. Here's one more you do task for you to practice today's skill before we put them to the test. Set another 10 minutes on your timer and then mark your work in the same way using the next slide. Off you go. If you've made it this far, give yourselves a huge pat on the back. We covered some tricky content today, so well done for keeping up. I would now like you to put your notes away or turn to a new clean double page in your books. This is your final task for today's lesson, the KPI test. Try the next 5 questions in your book in exam conditions. There's no time limit. Only once you've finished all 5 questions may you go to the last slide and mark your work in red pen. Leave me or Mr. Mitzi a comment on Show My Homework to let us know how you did. Remember, you can also use that function to ask us questions about any of the work from today's lesson. I am so proud of you, Year 8, for keeping up with your maths education during this time, and I can't wait to read your comments to let me know how you got on. Good luck on this test, and keep safe.